Good morning friends, I hope you are following the thermodynamic video lectures. The last class what we discussed means that we derived the equation for the what is the work done in the adiabatic process in terms of P and V, in terms of temperature also we derived. Now today our goal is to cross examine what happened about the adiabatic what happened for the first law of thermodynamics in the adiabatic process. So we are recalling the first law of thermodynamics, that is equal to the amount of heat supplied to the system is equal to the change in internal energy plus external work done dW, that is equal to dQ is equal to du plus dW. But as the process is the adiabatic process, there the Q must be constant, then change in energy of the system is equal to 0. The first law of thermodynamics can be written as 0 is equal to du plus dw. Then du is equal to negative of dw we are getting. This is the first law of thermodynamic modification in the adiabatic process. Then we will go to the sum of the conclusion in this adiabatic process. What is the first law of thermodynamics is telling? Du is equal to negative of dw. Now I am assuming that I am taking the case 1 like this. If a work is done by the system, that means if work is done, the first case I am assuming if work is done by the system, So as the conventional signs of the thermodynamic signs, if the work is done by the system is equal to the work is taken as a positive work, then dW is equal to a positive value. Then this value is substituting the above equation is equal to du is equal to negative of some positive value, that is equal to a negative value. Negative of positive value is equal to negative value we will get. Positive into negative is equal to negative only. That means what is indicating? If the work is done by the system, its internal energy will decrease us. So now the conclusion is nothing but in adiabatic process, in an adiabatic process, in an adiabatic process, if a work is done by the system, if work is done by the system, its internal energy will decrease us. Its internal energy decreases. Why decreasing? Negative sign I am writing. Du is nothing but u final value minus u initial value. This value is negative, that means this value is the lower value, this value is the higher value, then only it will get the negative sign. So that means internal energy at the final state is lesser than to the initial energy of the state at the initial state. That's why I am taking decreases. Now let me go to the case 2. Again I am writing first law of thermodynamics in the adiabatic process. Du is equal to negative of dW. I am taking case 2. In the previous case we assume that work is done by the system. Now present case we are assuming that work is done on the system. Now if work is done on the system, if work is done on the system, if work is done on the system means as per the convention signs in the thermodynamics, that sign can be indicated as the negative sign. Then that implies dW is equal to negative of work. Then by substituting in the above equation, that is equal to du is equal to negative, already is there, negative of negative value. That value is equal to is a positive value. Positive du is nothing but what is the final internal energy minus internal energy. That means this value is the positive, means this value is the larger value, this value is the smaller value. That means the final internal energy is more. Then conclusion is if work is done by the system, its internal energy will increases. The conclusion is nothing but if in an adiabatic process, we need to start this condition is we are writing in an adiabatic process. In an adiabatic process, if work is done on the system, its internal energy increases. This is the two conditions are most important, they may ask in your competitive exams. So the first condition is work is done by the system, internal energy will decreases. Work is done on the system, internal energy will increases. I hope you are enjoying this video lectures. Thank you for watching. Thank you.